Hello, I'm Jung Chul, the professor of computer science in ITC and IFP in Cambodia. Today, I will show you how to set up HTTPS using mode SSL on CentOS. Okay, this video will have two parts. Part 1 will focus on the basic concept on SSL and has 6 steps. Part 2 will focus on HTTP configurations from step 7 to step 9. So this one is the first video and will focus on from step 1 to step 6. In my case, right now, I have this kind of testing environment. The host name is serverchul.com and this one will be HTTPS server. And in the browser, I can see these contents using like this, https://www.chul.com. And the client chul.com, this one will be the client. This stems the host name and IP address like this. This one will be Linux web client, and this one will be used to test HTTPS on Firefox. Step 1, secure socket layer. We call this one SSL, and SSL has 2 layers and 4 protocols: SSL record protocol, handshake protocol, change cyberspec protocol, and alert protocol. And SSL record protocol located in the between TCP and layer 4 application layers. First, let's check the SSL record protocol service. SSL record protocol support 2 kinds of features, such as confidentiality and message integrity. Confidentiality is an encryption system to use symmetric cipher system, and this one will be encrypted by shared secret key. And normally this kind of secret key will be defined by handshake here. And for the encryption, handshake protocol will use this kind of cipher algorithm: AES, IDA, RC2-, triple-, Portager, and RC4 like this. This kind of the cyberspec protocol belong to the symmetric cipher algorithms. And for the confidentiality, message at first will be compressed before encryption. Second, message integrity. Normally, message integrity use MAC, message authentication code, with shared secret key by confidentiality. And this integrity is similar to HMAC, but the padding method is different from HMAC. Step 2, SSL record protocol operation. If SSL record receives the application data from higher layer, normally this kind of data will be fragmented, and each this fragmented data has the 16,384 bytes as a maximum data unit. And if this data is fragmented, and then next step will be the compression. But the compression is optional. And after that, the MAC message authentication code will be added these original data using SHA or MD5. And after that, this one will be encrypted by the shared key. And after that, this one, the SSL record header will be added these original data. This is the SSL record protocol. Step 3, SSL Handshake Protocol. SSL Handshake Protocol located in application layer. And this handshake protocol normally allows server and client to authenticate each other. It means server will authenticate client and client also will authenticate server. And also this one will be the negotiate the encryption and MAC algorithm. For example, encryption, there are many kinds. For example, like AES, DAS, triple DAS, or RC4 like this. MAC algorithms, like SHA-1MD5 like this. After they negotiate, they will later decide. And negotiate cryptographic keys to be used. What kind of keys they will use or not, like this. Number two, the comprise a series of messages in parts. This is a kind of step to make a handshake between server and client. First, they will make or establish security capabilities. And after that, number two, server authentication and key exchange, client authentication and key exchange, and they will finish. So here, this is the step. Pass 1, pass 2, pass 3, pass 4. In pass 1, client will send his hello message to server and server also will reply to this message. In pass 1, client and server, they will make security capabilities including protocol version like version 2 or version 3 like this. Session ID, cipher suit, and the confirmation method and initial random numbers. After they exchange this kind of information, then the parse 2 server will send this kind of information like a certificate and the server exchange, certificate request, server hello done. So if server send hello done, it means server finish this step. And if server finish number 2 to send this kind of information, then client will apply to this request from server, like a certificate and client key exchange, and the certificate verify for certificate from server, like this. And after that, pass 4, if server and client are successful to change certificate and key exchange, then they will change the cipher spec. At first, the cipher spec will be the pending state, but if they are successful to exchange this kind of information, then they will finish the current like this. And after that, they will finish this handshake protocol to send finished packet. Step 4, digital certificate. Digital certificate here, first you must know digital signatures. Normally for the signatures, we can use like RSA, LGAMA, or DSA. And this kind of algorithm has normally two keys, private key and public key. In signature, normally private key can be used to decrypt data and public key can be used to, private key can be used to encrypt and the public key can be used to decrypt the data. So if one key is used to encryption, then only the other key can be used to decrypt. For speed improved security, hash the plain text. The plain text is the original message and the signed, and after that, this data will be encrypted. And number 2, digital certificate. For the digital certificate, we can find the trusted third party. And this kind of trusted third party will sign our public key. For this kind of purpose, normally we use certificate authority. We call this one CA. And the CA has a public key, and this kind of public key will be known by anyone involved. And if the CA issue this kind of certificate, digital certificate, and the digital certificate will have this kind of information, server's public key and expiration date, and the information about the owner of the key, and information about the CA and the CA signature, and information how the certificate may be used, package installation like this. This is a digital certificate. And even if there are many kinds of several digital certificate format, normally we use this one, X.509 certificate. And X.509 certificate has this kind of format. First, the button number, certificate serial number, algorithm, the signature for signature, and issuer name, and this one period of the valid. Normally we will use 1 year for the valid period. And the subject name means the owner of this certificate. And here the subject, you mean the owner's public information, and the issuer unique identifier, subject unique identifier extensions, and signature by normally issuer. So X.509, the certificate has three kind of versions. Version 1 only has from version to the subject public key, version 2 until subject unique identifier, and version 3 is including extensions, and the signature by issuer belong to all versions. For example, if even if you receive this kind of the certificate 509, the certificate has the problem or compromised by attackers, normally you have to revoke this certificate. We call this one certificate revocation list. In this list, you can find this one. For example, this one, user certificate serial. Here, you can put revocation date, and here serial number for revoked certificate. Step 6, HTTPS. HTTPS means combination of HTTP and SSL or TLS to secure communication between browser, like from the client, and server from web servers. And the HTTPS, this protocol documented in RFC 2818. And even if you use SSL or TLS, there is no fundamental change. If you are successful to configure or to start HTTPS, normally we can use like this, number 2, HTTP protocol name HTTPS ://URL. Normally HTTP use like this to include port number 80, but HTTPS use port number 443. And if we use the HTTPS, this protocol will encrypt this kind of information, such as URL, document contents, form data, cookies, and HTTP headers. Okay, here I will finish the part 1, and part 2 I will explain how to configure or start HTTPS. Thank you for watching this video, and see you part 2.